Hey, welcome back to Math with Patrick. Today's September 29th, and we're solving problem 272 from the Daily Epsilon calendar. And the answer today should be 29 because it matches today's date. So we have two equations here, and we need to solve for x, and x supposedly is equal to 29. And like a classical approach to this would be to notice that we have some equation in terms of y right here. So we could solve for y. And then once we know what y is, we can plug it in here, and then solve for x. And honestly, that might work. Though I do notice something kind of similar between this expression and this expression. Like, I don't know, 14 and 49 both have a factor of 7. 2 and 4 kind of relate to each other. This term right here is just that squared, like 2y squared is equal to 4y squared. And so one thing I noticed here, I could take this first equation and distribute this denominator. And I'm allowed to do it. It's kind of like if I had, I don't know, like 1 plus 1 over 2. You would solve the top and get 2, and then 2 divided by 2 is 1. Or we can split the denominator kind of like this, where we share this 2 with the 1 and the 1. And 1/2 plus 1/2 is still equal to 1. So the same thing works with variables here as well. I can split that 2y, so I'm dividing it by the first and the second, kind of like this. And the reason why is because these terms can kind of cancel a little bit. The 14 and the 2 make a 7. Y squared divided by y is just y, and I'll leave this part alone for now. So this term right here, squared, is that. This term right here, squared, is that. And I mean, I would love it if I could just square this and square that and square that, but it doesn't really work that way. Just for a quick example here, I know that like 3 squared plus 4 squared does equal 5 squared, but I also know that 3 plus 4 is not equal to just 5. So we can't just like selectively square things and hope that it works. Instead, I still will square it. And I'm hoping that this kind of middle term that pops out will be kind of easy to use. So I can square both sides like this. On the right side, I will get 36. On the left side, whenever you do a binomial times a binomial, you need to do first times the first, that is 49y squared. And then you'll do twice this product right here. So I need to do 2 times and then 7y times 1 over 2y. And I guess I could just collect it up kind of like this, because 7y times 1 over 2y is the same as just putting that 7y in the numerator there. And then finally, 1 over 2y, we square this last term right here. It times itself gives me 1 over 4y squared. And so this term is right here. This term is right there. And both of those added together equal x. So I can just use some substitution here and replace both of those with just the letter x. Oops, not x equals just yet, because I still haven't addressed this guy in the middle. If I have 2 times and then like 7 divided by 2, both of these 2's can just kind of cancel each other out. And then also a y on the top and a y on the bottom will also cancel each other out. So that term right there is just a plus 7. So we have x plus 7 is equal to 36. And the only number out there that would work for x is a 29, because 29 plus 7 equals 36. So there is my answer. I think this is the intended solution, because solving down for y right here might be pretty hard. So there it is, x is 27, and I think we're all done. So thanks for watching, and I'll see you tomorrow. Bye.